Hello, geometry students. Today we're going to start a new chapter. We're looking at the beginning of Module 11. This is going to be into a lot of area and measurement, and we're going to start with 11.1, which is the areas of quadrilaterals. So we start with just some vocab. Base of a parallelogram is any side of a parallelogram. Altitude of a parallelogram is a perpendicular segment between any two parallel bases, and all these are going to be labeled in the diagrams that we're going to see, but these terms, this vocabulary is going to come up in these formulas for the areas. So just having this all in one spot is going to be a little helpful. The height of a parallelogram is the length of the altitude, which is from up above, one statement above. Decomposition is just separating them into two or more non-overlapping parts. We're going to see some of that throughout the chapter. And then the height of a trapezoid is a perpendicular distance between the bases of a trapezoid. So again, not something you need to remember verbatim, but those terms are going to come up in these diagrams that we're going to see here with parallelograms. So there's some pretty good images on the McGraw-Hill stuff that I pulled for some of this stuff. So starting with parallelograms, any of those sides can be considered a base. And then the height is just whatever base whatever side you're calling your base, whatever one is sitting flat, you're going to consider your base measurement. The height is just the perpendicular measure across the shape from that base. So then a quick little image here, really when we're taking the area of a parallelogram, it's just going to be the base times the height, because when you cut off one of those triangles on the left-hand side, that you can see the image on the left, so they're removing the triangle from the left and moving it over to the right, you really just end up with a rectangle. So the area for a parallelogram is just the base times the height. So again, the base is whichever one of those sides you're going to call the base, and then the height is that perpendicular length off of it. So one quick example here, and this is something where this image, it depends on how you're going to look at it. So we might want to say, well, it's sitting on 13. 13 looks like the base. I don't know what that height is. Well, again, with a parallelogram, it doesn't matter. They're giving you the height off of that side length of 14. So we can just turn that around. Consider 14 your base. 9 would be your height coming off of it. And then we're just going to go right ahead and say that the area of this parallelogram, base times height, is going to be 14 times 9, which will end up being 126. And they do want you to label this correctly. They give you these options like this. Whatever the unit is, they give you the three options of just the yard, yard squared, or yard cubed. Obviously, yard cubed would be volume is the cubic measure. So we're going to say 126 yards squared. And that's all you're doing with the parallelograms. Trapezoids, they talked about it a little different than how I usually express the formula. We'll see down at the bottom, but I turn it into kind of my own terms that I usually like to explain. So again, so the trapezoids, the bases, you could call either one of those the base, is going to be the set of parallel sides. So again, no matter how it's sitting, you're going to treat one of those two parallel sides as the base, and then the height is just the distance between it. And more often than not, so they have it measured on the outside, more often than not, you'll see that height right in the middle, okay, somewhere in there. Pretty regularly it comes off of one of those triangles. So then you have a 90-degree triangle, you can do some Pythagorean theorem stuff to find the height. Anyway, there's quite a few scenarios where that triangle in this shape will come into play. So they started with this trapezoid, and then what they're doing in this second image is they're explaining how this is very close to the area of a parallelogram. Again, I don't love this, but I think it's a decent visual. So what they're doing is they're doubling that trapezoid to turn it into a parallelogram. So you've got two sets of parallel lines. And then they're saying, okay, well, back to the area of that original shape we had is cutting half of that out, the one that we doubled. So it's the same equation as the area of a parallelogram, but cut in half with the two bases combined. Again, we're going to get down here. I'm going to relay this into how I usually teach the area of trapezoids. So what they're saying there, the area of trapezoids is 1/2 of the height times base 1 plus base 2. Really, and we saw this back in module 7, when you had a trapezoid, we found that that middle value was going to be the average of the two bases. It was cutting the trapezoid in half from top to bottom. So that is your base average. Okay, that's what I like to use for, that's what I like to use for this area formula, because that 1/2 and the base 1 plus base 2, that is just you finding the average of your bases. So the top base plus the bottom base divided by 2 is that base average. So if we look at it more like this, I think it'll be a little easier to wrap your head around and a little easier to solve too. So it's the height times the average of your bases. And we have found that base average. We did that in module 7. So that is something we have seen and done before. So that is your area of a trapezoid. So some of this talking through those things might be a little confusing, but let's look at an example. So your two bases, okay, your base 1 is 18, your base 2 is 4. So again, if we're looking for that kind of base average term, 18 plus 4 equals 22, divided by 2 equals 11. So 11 is like your base average. Okay, that's the term we're going to use, or the value we're going to use when we're finding the area now. So we've got that height of 4, and we've got the base average of 11. So area equals base average times height, and that's going to be 11 times 4, which is going to give you 44. And that's going to, of course, be feet squared. So you end up with 44 feet squared for the area of that trapezoid. Okay, now there's a couple of examples tied to the kites and rhombi. Rhombi is the plural term of rhombus. So just remember the difference between rhombus and the kite. The rhombus is basically just a square pushed over towards the side a little bit that's leaning, just without 90-degree angles. All four sides are congruent. A kite, they have two adjacent pairs of congruent sides. So they do not have anything congruent opposite-wise, or there's nothing parallel. There's nothing like that going on, if we remember from our conversation with kites. But the area formula for both of them is just 1/2 of diagonal 1 times diagonal 2. So if you know the two complete diagonal measures, you just multiply them together, cut them in half. So that is going to be your area formula for both kites and rhombi. So this first one's going to be pretty straightforward. AC is 14 and BE is 12, which makes the entire diagonal there BD 24. So AC is like your diagonal 1, that equals 14. BD we can call our diagonal 2, that's 24. Okay, so you multiply those two things together. So I didn't do that beforehand. Let's multiply those together here. 4 times 4 is 16. 1 times 4, and then 5, that's 8. 280. Okay, I think that's right. 336. Okay, so that is your two diagonals together, but remember, area equals, we can write it this way, diagonal 1 times diagonal 2 divided by 2. It's 1/2 diagonal times diagonal. So then you're going to be looking at 336 divided by 2, which is going to be 168, and in this situation, centimeters squared. Okay. All right, now just these last couple examples. No more new formulas, but you're going to run into these situations where they're not giving you the diagonal measures. They're actually giving you, so AB is 10, AC is 12. So they do give you one of those diagonal measures. Okay, if we want to say AC is diagonal 1, that's 12. Well, we're looking for that other diagonal measure, which would be BD again, and we don't know it yet. But the diagonals intersect at a right angle. So we have a situation where we can use a Pythagorean theorem. So you're going to have to use, and we kind of mentioned this, I said in that trapezoid question, where sometimes they're going to play off the triangles here. So we're going to take half of that AC, which is 6, to AE. So we've got a right triangle right now with one of the legs 6, the hypotenuse of 10. If you know your Pythagorean triples, you might already know this answer. If not, we've got 6 squared plus b squared equals 10 squared, which will be 36 plus b squared equals 100. Subtract 36 from both sides. You're going to end up with b squared equals 64, and then your b would equal 8. So if I know BE is 8, then I know that entire diagonal is twice of that, which is 16. Okay? So now I've got my area ready to be calculated. Again, it's that 1/2 D1 times D2, which is going to be 1/2 times 12 times 16, which I'll save a little bit of the work here because I'm about to run out of time. I think your area is going to end up being 96 centimeters squared. And again, we have that centimeters squared that we're going to select on the Alex question. Okay, so we got 96 centimeters squared, and that's done there. Okay, so again, same formula with the kite and the rhombus, but you might not be given that information. You might need to use those right triangles to go find it. Then the last one is there's going to be a couple of these shapes on a coordinate plane. Now, from what I've seen in all the different questions, I've just looked at a few of these on Alex. They're making it pretty easy on you. For a trapezoid, again, we're using the terminology that the area is equal to the base average times the height. So in order to find that base average, we need to know these two measures, base 1 and base 2. And we also need to know the height. That is perpendicular. Well, they made this pretty easy on us with these two bases just being vertical lines, so we can see how far apart those two endpoints are, and then we can also see how far apart the lines themselves are. So that measurement for, let's say, this base here, my drawing has gotten rough, you're looking at the change in y. So that's going to be 12. And then for the other base, again, that vertical change in y, 6 and -2, that's going to be 8. Okay, so for those of you that are quick here, your base average is going to be 10, right? 12 plus 8 is 20, divided by 2 is 10. So your base average that you're going to use in your formula is 10. Your height, we are just going to be looking then at those x values. I kind of covered it up. That's a 5, and that's a 2. So the distance in the x values between those two is going to be 3. So all you need to worry about, your average is 10, or excuse me, your area is 10 times 3, which is going to be 30, and they just have it as square units since it is on the coordinate plane. There's not an exact measurement of units. And that's it. And we're about out of time. Homework is on Alex. We will see you guys tomorrow. We can take questions on this if we need to. Have a great rest of your day.